Hey, we are going to talk about 8.2. Hopefully, you have already printed those notes. So it's right here, and I'm going to put the video right here. Printed or just wrote down on your notebook. So I'm going to make this bigger, and we're going to go over 8.2. So 8.2 is about testing a claim about a proportion. So it's similar to the first section, 8.1. So there are two ways of testing a claim about a proportion. So we have the normal approximation to binomial, and then the other method using technology. So the normal approximation method is going to approximate it to a binomial with a binomial distribution. So here are our key elements. So these are the notation. This is the notation. Remember, p hat is your sample proportion. P is your population proportion value used in our null hypothesis. And then Q is going to be 1 minus P because P and Q are opposites. Together, they make 1. So the requirement, simple random sample. Then we need to check the binomial distribution requirements, which is fixed number of trials. Trials are independent. Each trial has 2 categories, success or failure. And the probability of success remains the same in all trials. Number 3, you need to check these conditions. N times Q is greater than or equal to 5, and N times P is greater than or equal to 5. And then you can do mu, approximate mu as N times P, and standard deviation is square root of N times P times Q. P is assumed proportion from your null hypothesis. It's just another reminder there. Your test statistic, this is what we're going to need to find. You use this formula and you find the p-value using the table or technology, and then critical values using standard normal distribution. So let's think back to our drone example from 8.1. I think it was 2009. I don't know what I'm thinking. What, 2008? Yeah, it's 2009. Sorry. Okay, so 54% were uncomfortable. The claim, we're going to test the claim. Majority of consumers are not comfortable with drone delivery. Check your requirements. So is it a simple random sample? Yes. I need a different color. Yes. Fixed number of trials? Yes, we have 1,009. Independent, they're all independent of each other. Yes. 2 categories. We either have comfortable, or uncomfortable. So check. Probability of success remains the same. Yeah, it's all half. You're either comfortable or you're not comfortable. We need to check N times P is greater than P, greater than or equal to 5, and N times Q is greater than or equal to 5. So N would be 1,009 times, I forgot to write what P is. P is half. That's probability of success. Q is also half. You're either comfortable or you're not. So times 0.5. Well, we know that's going to be greater than or equal to 5. Let me get my calculator though. So 1,009 times 0.5 would be 504.5. Is that greater than or equal to 5? Yes. Same thing here because you have the probability of failure is the same, or success. Okay, so we're good there. Use technology, the calculator, 1 prop z-test. So let's see, we want to do stat, calc, test, sorry. 1 prop z-test. Our P, that's majority. Remember we talked about majority being 0.5. 545. Is that how many there were? I think it was. Let me look back at it. At that problem. I think it was 545. Yep. That's what it was. And then we want it to be greater than 50%, which is majority. So we're going to calculate. So our Z is 2.55. Our P is 0.5. Oh, no, sorry. I'm getting a phone call. Hang on. I need to decline right now. Okay, sorry. I don't know how to get rid of that. Maybe. No, I don't know. I don't even know where the phone call's coming from. I have no idea. Let's see. Yeah, it might have been my Google Voice number. I don't know. I can't find things. It's a mess. Okay, so this is not your P that we used on the other. This is our P value, which is 0.005. Okay, so our null hypothesis was that P, meaning the proportion, equals 50%. And our null was that P is greater than 50%. Okay, so we found our P value, we found our Z score. Okay. So our significance level is 0.05. Z is 2.55 from the calculator, and that's what we found. We could have also used this formula. It would have come out the same thing. And then our p-value comes from A2 going to Z. So I can show you that using your calculator, using your table. So you look for 255. We're on the positive Z scores. 2.55, and I'm at the very back of our textbook. It's the back cover. So 2.55, 2.55 is 0.9946, right? So we would do 1 minus that to get our p-value. 1 minus 0.9946. And so that's where the p-value comes from. Okay, so the result, there is sufficient sample evidence to support the claim that more than half of consumers are uncomfortable with drone deliveries. And so the reason we knew that is because this 0.005 is less than 0.05. This is your p-value. You want it to be less than your alpha, your significance level. So since this, you are going to reject null. So if we reject null, then that means that we have enough evidence to support the claim that more than half of consumers are uncomfortable with drone deliveries. Okay, so we need to back up just for a minute over 8.1. We're going to talk about type 1 and type 2 errors. When testing your null hypothesis, we can either reject the null or fail to reject. Okay, our conclusions can be wrong sometimes, even if we've applied the procedures correctly. So we have two different types of errors. We have a type 1 error, the mistake of rejecting the null when the null is actually true. Type 2, the mistake of failing to reject the null when the null is actually false. And all this is saying is reject the null given the null is true. So anytime you have this line here, that means given. Or knowing that the null is false. Okay, so here's a little table that tells you about the different types of errors. So let's say we reject the null. There are two things that can happen, or two things that we know. The null hypothesis is true, or the null hypothesis is false. If we reject the null, we want We want to do null hypothesis is false. We want that to be the case. And that means that you did a correct decision. However, if you rejected the null, but the null is actually true, then you have made a type 1 error somehow. Okay, what if you fail to reject the null? If you fail to reject the null, then that means that the null hypothesis could be true. So that is a correct decision. But if you fail to reject, but the null is false, that's a type 2 error. Okay, so example to distinguish between the types of errors. Rejecting a perfectly good parachute and refusing to jump. That would be a type 1 error. Okay, failing to reject a perfectly good parachute and jumping out of a plane with it. That's a type 2. Okay, so those are your two different types of errors. So that's just a way to think about it. Help on remembering the errors. Use only the consonants in the phrase. Routine for fun. So RTN, that's a type 1 error. Reject the null. Type 2 error is FRFN. Fail to reject false null. Okay, so those are your two different types of errors. P-values, remember those are your common p-values. A small p-value is preferred because it corresponds to the sample evidence that most strongly supports the alternative hypothesis that the method is effective. So we want, if you were to choose a p-value, if you want strong evidence to support the claim or to support the hypothesis, then you want one of these small, that's probably the best one to have the best evidence. Okay, here is an example. Fewer than 30% of adults have sleepwalked. Olivia sleepwalks almost every night. I don't know if she sleepwalks, but she comes into our bed every night and she doesn't remember. So, yeah. Yes, I'm talking about you. Shut the door. Okay, so N is 19,136, and then our P hat is 29.2. Use a significance level of 0.05 to test this claim. Okay, so is it a simple random sample? Yes, because they just asked people. Fixed number of trials? Yes, we have that. It is that many, 19,136. We need to check this. So we know that P, we want fewer than 30%. So our N times P, let me double check. Okay. If we were to multiply the claim in symbolic form, so this would be N times P. P is the 29.2. No, it's you either have sleepwalked or you haven't, so it's 0.5. And Q is 0.5. So if you did half of these, you would get, I don't know, 19,136 times 0.5, 19,136 times 0.5. That would be 9,568. That's greater than or equal to 5. Same thing here. So either you have sleepwalked or you haven't. Okay, so write the claim. So the claim is that the number of people is greater than, fewer than, is less than, sorry. Where's my, I don't know where mine is. So P is less than 30%. Okay, so write the hypothesis. It is going to be the original claim in symbolic form is P is less than 30%, the opposite of the claim. So the hypothesis, so the null and the alternative. So the alternative is actually what we want. P is less than 30%. So the alt is going to be that it equals. And that's what we're testing. Okay. So our significance level is going to be 0.05. Okay. So we want to use the calculator. So we're going to go to stat, test, one prompt z test. They are, this is our null hypothesis, or the value that we're testing. So that's a 0.3. And this would be 29.2% of this. So we can actually put that in together. 0.292 times 19,136. And when we do that, it'll actually multiply that for us. Okay. And then our N is the 19,136. And we want that it's less than. So we'll put that. Okay, calculate. Oh, what did I do wrong? Stat, test. Oh, I gotta round this up. There we go. Okay, so we have that our z-score, our critical value, is negative, or our test statistic, sorry. And then our p-value is 0.00796. So we're going to round that to 8. Okay. So looking at this, 0.008, and we're comparing it to our significance level. And so we know this is less than that. So that means we are going to reject the null. So if we reject the null, then that gives us supporting evidence to show that fewer than 30% have sleepwalked. So there is sufficient evidence to support the claim that fewer than 30% of adults have sleepwalked. Okay, so let's look at, we should have a few more pages. So this is the exact method for testing. So the first one was using the approximation. This one is the exact. So we are not estimating using normal distribution. We are getting the exact results by using binomial probability distribution itself. That doesn't require the n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Steps. First, you're going to identify the sample size in number of successes x, and then the claimed population proportion used in your null. And you're going to determine if it's two-tailed, left-tailed, or right-tailed. So remember, left-tailed is going to be less than. It's whenever you have x or fewer successes. Right-tailed is whenever you're talking about the greater than, x or more successes. Two-tailed is going to be whenever you're looking at just the middle part. So twice the smaller of the preceding left-tailed and right-tailed values. So here's a problem. A certain drug used to treat asthma. In a clinical trial of the drug, 24 of 264 treated subjects experienced headaches. The calculator display shows results from the test of the claim that less than 8% of treated subjects experience headaches. Use normal distribution, approximate a binomial distribution, and assume significance level of 0.05. Okay, so you're given the calculator output. And we are going to identify information from that calculator output. So your test statistic, first thing, left-tailed, right-tailed. So this is less than. So if it's less than, it's going to be left-tailed. The test statistic is your Z, 0.653. All right, p-value twice. Your p-value is 0.743. Who knows what I was thinking? And then your null is less than 8%. So it's actually that the proportion equals 8%. Okay, so we look at our p-value. So what does that p-value tell us? We're using significance of this. So we are going to look at our p-value and compare it to our significance level. And this is actually greater than. So if it's greater than, we are going to fail to reject. Because this was greater. We want it to be less than the significance level. So our final conclusion is that we don't have enough evidence to support the claim. So there is not sufficient evidence to support the claim that less than 8% of treated subjects experience headaches. All right. Okay, the next example. A poll of 1,999 randomly selected adults showed that 90% of them own cell phones. The claim is that 92% of adults own cell phones. Use the normal distribution as approximate to the binomial distribution, assume that our significance level is 0.05, and the data below from technology to answer the questions. Okay, so our test is, this is our claim. So our claim, which is going to be our alternative, our null, right? Null. Okay. And we are going to look at P of 92 versus not 92. So we have this information. We need to look at what kind of tail is it. Since it's equal, it's going to be a two-tailed. Our test statistic is going to be the Z, so negative 3.39. Our p-value is 0.001. And then our null hypothesis is 0.92. And our alt is that it doesn't equal 0.92. Our conclusion, we are going to look at our p-value. Our p-value is 0.001, and we're comparing it to our significance level. So this is actually less than. So if it's less than, we are going to reject the null. Okay. So since we reject the null, then there is significance or sufficient, evidence to warrant rejection of the claim that 92% of adults own cell phones. So we are rejecting the null, and the null was that it equals 0.92. And that was basically our claim. So whenever you do equals, your claim is going to be that it equals that proportion 0.92. And so your alternative is going to be that it doesn't equal 0.92. So because our p-value was less than the significance level, then we are rejecting the null. So we're rejecting the null, rejecting that claim that 92% of adults own cell phones. Okay, this is our last problem. Consider a drug that's used to help prevent blood clots in certain patients. In clinical trials among 6,267 patients treated with this drug, 168 developed an adverse reaction of nausea. Use a significance level of 0.05 to test the claim that 3% of users develop nausea. Does nausea appear to be problematic adverse reaction? All right, so let's look at what X is. Is the 168. N is your total sample, 6,267. And we are testing the claim. The claim is that, let's see, 30% of users develop nausea. So 30% develop nausea. Okay. So we are going to write that as P equals 0.03. It's a proportion we're looking at. So our hypothesis is that P does equal 0.03. And our null, our alternative, is that it doesn't equal 0.03. Okay, so let's use our calculator. So we are going to do stat test on prop z test. And so our p-value is 30%. Oh, I didn't put that in 0.3. There we go. X is the 168. N is 6,267. And we are testing that it doesn't equal. Okay, go down to calculate. That was a one. All right, so we have Z from our calculator. We got the Z equals negative 1.48. And our p-value is 0.1384. Okay. So we need to look at this in the significance level. So it told us that significance level is that. So we're going to compare to 0.05. And so this is greater than. So since it's greater than, we are going to reject the null. No, we are going to fail to reject, sorry. Because the other one was a p-value that was less. So since it's greater than, we are going to fail to reject. Okay, so that means that there is not sufficient evidence to warrant rejection of the claim that 3% of users develop nausea. Okay, so and then the last question was, does nausea appear to be problematic adverse reaction? Since it's not 3%, it's actually less. So since the rate of nausea appears to be relatively low. So if it was high, then you'd have a problem. But it's relatively low. It is not a problematic adverse reaction. Reaction. Okay, so that is all the notes I have for you. One thing I want y'all to remember, which I wrote it over here. I'll show you it. If the p-value is less than or equal to your significance level, then you're going to reject the null. If the p-value is greater than your significance, you're going to fail to reject the null. Okay, so that would be important to remember. All right. We all have a great day, and I will see you on the next video.